All right. Choose an American farm at random and measure its size in acres. Here are the probabilities that the farm chosen falls in several acreage categories. Let A be the probability that the farm is less than 50 acres in size, and let B be the event that it is 500 acres or more. Find the probability of A and the probability of B. So what is the probability of A?
0.29.
How'd you get that?
I added together all the ones that are under 50.
So 0.09 plus 0.20 is 0.29. And probability of B, not probability of 5, probability of B. 0.09 plus 0.05 plus 0.04, 0.18. All right, describe A complement in words and find the probability of A complement by the complement rule.
So I guess that the A complement would be
How would I say it in words?
that the probability that the farm is greater than 50 acres in size.
Farms that are 50 acres or more in size. And how do I find it? Using the complement rule. Probability of A complement is 1 minus the probability of A. Yep. Which is what?
What the 0.71.
Yep. Describe A or B in words, so explain what that means, and find its probability by the addition rule.
Did we already do that?
Wait, so
No.
A is what the
So what is,
possibility of farms that are less than 50 acres in size? Is that what it's asking?
so explain what the, like,
Oh.
what A or B means.
Oh.
So like the probability that the farm is either less than 50 acres in size or 500 acres or more.
Yep. This means the farms that are less than 50 acres or 500 or more acres. And how do I find the probability of A or B?
A plus B.
Probability of A plus the probability of B, which is 0.29 plus 0.18, which is
0.47.
Get off the thing for a second. 1.4.
I know. I had to figure that.
not 0.1029. Last night I really was sitting there trying to figure it out. Still haven't figured it out.
Figure what out?
That the movie quote that you were trying to think of yesterday.
Point.
Point
0.1029.
break the point.
I didn't figure it out.
I don't know. It's gonna drive me crazy. One day I'll figure it out or I'll forget about it. Next time I hear that line and whatever it was, I'll be like, "That's what that was it." All right. Choose an American at random. Define 2 events.
Choose an American out.
A is the person has a cholesterol level of 240 milligrams per deciliter of blood or above, which is high cholesterol. B is the person has a cholesterol level of 200 to 239, blah, 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 which is borderline high. According to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. Explain why events A and B are mutually exclusive.
Like, why they're
Because
independent
they're
of each other?
independent of each other.
Like, is that
But
what you're
why?
asking?
I mean,
Their
basically.
ranges don't
results
don't
don't
know
affect
that.
one another.
Can someone have borderline high and high?
No.
No. So you have to be one or the other. So a person either has high or borderline high cholesterol. Can't be both at the same time. All right, say in plain language what the event A or B is, and then find A or B. So basically, say it in words and then say it in math.
Don't they already tell us what A and B is? Like,
Well, I guess within the context, basically.
Just like we did up here with A or B
Yeah.
in the farm.
So we need to talk about cholesterol for farms.
so A is representing levels of high cholesterol and B representing borderline high cholesterol.
Yep, so is someone with high cholesterol or borderline high cholesterol. So what is the probability of A or B then?
Gotta add them up, right?
So 0.16 plus 0.29, which is
0.3.
nope.
Wait,
7.
no, 0.4. 5.
0.45. If C is the event that the person chosen has normal cholesterol, which is below 200, what is P of C? The probability of C.
Oh, so we can.
So you should do like 1
Figure
minus
that out.
0.45.
So 1 minus the probability of A or B, which would be 1 minus 0.45, which is
Point.
0.55.
55.
yep.
Oh, yeah,
All right. 10. You have two sets. Set 1 is A, B, C, D, E. Set 2 is K, L, M, N, O, P. If you pick one number from each set, letter, not number, letter. What is the probability that you pick at least one vowel?
So there's like a 1 out of, or 2 out of 6, 2 out of 5 chance for set 1, and 1 out of 6 chance for set 2. That's the start, I guess.
Okay. So there's 2 vowels in set 1, 1 in set 2. I want the probability of at least one. What does that mean?
Complement.
Okay. Think complement, but what does that mean? At least one means
It can be 1 or 2.
one or, yeah, one or more. In this case, 1 or 2, because we just need 2. So think complement. So I should think what?
No vowels.
1 minus the probability of no vowels. So this is going to be 1 minus, and then I would put in parentheses because we have 2 things we need to look at. So how many not vowels are there in the first one?
3.
So 1 minus 3 out of 5 times how many not vowels are there in set 2? So then 5 out of 6. So that's going to end up being 1 minus 1/2, which is 1/2 or 0.5. So basically, there is a 50% chance of picking at least one vowel. Last one.
Wow.
Long one, but last one.
Oh.
I told you we had like 3 questions, but like 2 pages. Wait, so they're still there? Oh wait, no. I actually have 4 questions. No.
Close enough. We knew what you meant.
Yeah.
Okay. A new clothing store advertises that during its grand opening, every customer that enters the store can throw a bouncy rubber cube on a table that has squares labeled with discount amounts. The table is divided into 10 regions, 5 regions with a 10% discount, 2 regions with a 20, 2 regions with a 30, and the remaining one with a 50. So I would start out by figuring out the probability of each thing occurring before we go any farther, because at least having the fraction written there, because ultimately we're probably going to need it throughout the problem. So the 10% discount, there are 5 of them, 5 regions out of 10. So I'm just going to write 5 out of 10 so that everything is consistent. 20%, there are 2 regions for that, so it's 2 out of 10. 30%, also 2 regions, so that's 2 out of 10. And 50% is 1 out of 10. So that way, I just have that going forward. And it's, yes, I could reduce them, but this way I keep the common denominator so that if I don't convert them to decimals, it just makes it easier when you actually are plugging them in and stuff. But if you want to make them decimals to begin with, you can do that as well. So what is the probability that a customer gets more than a 20% discount?
3 out of 10.
Okay, well, how are you getting that? Can't just give me an answer.
Adding the probabilities of everything that is greater than 20%.
Okay, so I can do the probability of 30% or 50%, which would be 2 out of 10 plus 1 out of 10, which is going to give me 3 out of 10 or 0.3. Now, this problem was such that we could do it this way, but we also could do it another way.
So 1 minus.
We could do 1 minus the probability of 0.10, or sorry, 10% or 20, and then do 1 minus 5 out of 10 minus 2 out of 10, which would have given us 3 out of 10 also. So either way would have worked. This one is kind of the same amount of work either way, so it doesn't really matter. But on ones that had a lot more options, it might be easier or harder to do one or the other. Okay, what is the probability that a customer gets less than a 20% discount? What does that mean?
Less than 100%.
So it'd be the probability.
Probability of 10.
So that's just the probability of 10. I thought when I said, what's the probability of less than 20, and Peyton was like, so less than 20%. I was like, that's what I just said.
No, I was just kind of like.
And I was like, oh, she's just reading the question.
I like repeating it.
So we said that's 5 out of 10, which would be 0.5. What is the probability that the first 2 customers both get a 50% discount?
That's a crazy one.
Yeah, that's crazy. I'll shut down the discount thing right then.
So you have to multiply like with the probability stuff by 2.
So multiply 50 probability.
Well,
of 50
we're not
by-
multiplying by 2.
It's like the
Probability of 50 times
square.
probability of 50 of 50.
Yes. So it's the probability of 50% times the probability of 50%. So that's going to be 1 out of 10 times 1 out of 10, which is going to be 1 out of 100, or 0.01. So basically there's a 1% chance the first 2 customers get a 50% discount. Me too, especially if there's a lot I need to get. What is the probability that none of the first 3 customers get more than a 30% discount?
Okay, so that.
Does that mean that they can get the 30%?
Should you use
So that would
Yes,
be-
they
should you
can
do,
get
like, a
30.
compliment
Mhm.
thing and then or just raise the check?
Yes, compliment.
Not like I was gonna say that.
All right, so this is going to be. So basically, this is just saying that none get a 50%. So this is going to be 1 minus 0.1. That's minus the probability that they get a 50%. And that's for each person, so then we're going to cube it. So 0.9 cubed is. What is the probability that the first customer to win a 30% discount is the 6th customer that enters the store?
Well, we're getting way too far into numbers now.
Yeah.
Calm down.
Just wait till the next couple of chapters.
Yay.
Okay, so we're gonna have to. Is we do compliment, like.
Sort of.
So if
Yes, but to save writing, I'm going to raise it to a power.
So like the not 30%,
Because that means the first 5 customers get what?
10%, 20%, or 50%.
Okay, so I would add all of those percentages up. What is that?
Like
0.8. So that's the first 5 customers, so we raise that to the 5th power.
Times.
And then the 6th customer gets
probability
30%,
of 30%, which is 0.2.
times 0.2.
How many decimals do we run up to? Or do you just want
3.
0.066?
All right. What is the probability that there is at least one customer to win a 50% discount among the first 5 customers that enter the store?
At least. So it means
Yeah, that's in there. Sorry.
Compliment. So what am I doing the compliment for?
let me read it. Would be 1 minus probability of 50%. To the fifth?
Everything other than the 50%.
Everything but 50%.
Everything but 50%.
So it'll be 1 minus the probability that none of the 5 win a 50%. So that's going to be 1 minus 0.9, but 0.9 is raised to the 5th. Because we're talking about a group of people not getting that.
Okay.
Right, okay. .409.
Josh, the next digit after the 9 is a 5.
Yeah, I know.
So it should have rounded
Round
up.
it up to 0.41, and you can add a 0 if you want to.
I'll just call it 0.41. All right. As you enter the store, you watch 4 people in front of you all win 50% discounts. The store manager tells you how lucky you are to be throwing the cube while it's on a hot streak. But with you says you're unlucky because the streak can't continue. Comment on these
It
statements.
goes down.
That's wrong.
7 can't
Because
Why?
what is it called? It's the
They're using the law of averages incorrectly.
law of averages doesn't
Oh,
exist.
the law of large numbers incorrectly.
One of those
Well, and
doesn't
the law of
exist.
averages.
One of them doesn't exist.
Yeah, they're implying that there's such a thing as the law of
Yes, and
averages.
they're not using the law of large numbers correctly.
Okay, so
Right.
why? Why?
There's no guarantee of things happening.
What's true about each throw?
It's
random.
independent.
It's independent.
Yeah.
That.
Okay.
One doesn't like affect the other one.
So that means that every roll has the same chance of getting a 50% or a 10% or whatever it is. So each throw is independent.
So it's turns.
I mean, like that's literal. That's not obvious.
What y'all said was fine. I mean, you can.
I just didn't know how to really put it into words. I knew
I
what
never-
I
I
knew
never-
the answer.
I never know how to put it into the words.
Yeah. Yeah.
But like,
The words.
Each throw is independent, so prior rolls don't affect the outcome of future rolls. People don't understand that when they go to the casino.
for real.
Mm.
What if someone throws it so hard that it like makes the pin deformed?
Well, what are they?
Well,
how do they get-
okay, that would affect your throw, I guess.
They might make you do it again if you.
The probability is 10% for every throw or every roll for a chance of getting a 50% discount. So, neither statement is correct.